I want to welcome everybody to our senior project presentation. This is our project presentation for the spring of 2021. And our project is based off a smart street lighting system. And my name is Steven Salcido.
My name is Guadalupe Quinones.
I'm Esteban Linares.
I'm Irvin Juarez.
I'm Jonathan Street.
All right, so let's get started. I'm going to give you guys a basic introduction for our project. Our project is basically a smart street lighting system, but it's obviously a miniature model. We obviously don't have the means, the time, or the materials to create a life-size model. But the thought process behind this was that with creating a miniature model, we would do enough research and be able to understand at least how the miniature model works, and we could maybe understand how a real life model works. So this system is a system that basically, it uses motion detection to activate street lighting systems. There are companies that have already implemented this in real life. They use internet, it's basically an Internet of Things system in real life. There are companies such as Verizon, such as City&Tele, and such as Cient. These companies have already created this product, their own versions of this product, and it's pretty much available to any company, any city, any it could even be a small town. But this system is basically a real life system. It's actually used in real life, and there are real companies pushing this product out there as part of maybe a green energy, solar energy, renewable energy movement.
So why did we choose this project? Well, of course, it's a renewable energy source. It's based on solar power, the cost efficiency, and its low maintenance. And also the being itself a renewable energy source, it solves polluting sources that are used in this day. Also, studies have suggested that it discourages criminals from committing crime acts. So if we have a vehicle passing by, a bicycle, or a citizen, the system will automatically detect them and the light pole will light up. So like I mentioned, the study suggests that it discourages criminals from committing those acts. Next, please. So our target audience is power and energy company, also bigger corporations, of course, and startup investors. Some of these power and energy companies are Pacific Gas and Electric, Edison, AC Electric, Imperial Irrigation District, and another big one is the LA Water and Power Department. Sensitivity systems and Petra systems that are listed below, these are light-based companies that are sensor-based and solar-powered. So these are startup companies, or they've been there for a while as well, as other companies, and we want them to recognize this project. Next, please.
So here we have an overview model of the system. Basically, a car will go down the road and the street lights will turn on, which are activated by a sensor that detects objects. This sensor is known as an ultrasonic sensor, also known as the HC-SR04. What this does, it transmits a sound wave that will reflect off an object if one is present, and it'll bounce back to the sensor, and this sensor will then give a feedback to the microcontroller. Next slide, please. So we were originally going to use an IR sensor, but after trial and error, we noticed that it wasn't going to be suitable for this project. So we came up with the idea to use an ultrasonic sensor, since it is more accurate and better suited for this project.
So to make our project more efficient, we have chosen to implement a solar charge controller for maximum power point tracking. The goal of maximum power point tracking is to ensure that the maximum power is always extracted from the solar panel. The more power we can extract from an array of solar cells, the smaller the array needs to be, making the project less disruptive environmentally. One of the primary drawbacks to solar energy is due to changes in irradiance and temperature conditions. Low levels of irradiance and high temperatures can cause solar efficiency and output to decline. Our goal is to ensure that we can minimize the effects of these environmental factors on our system. There are many different control methods to implement maximum power point tracking. A common method is the perturb and observe method, which we have chosen to implement in our project with an Arduino microcontroller. The perturb and observe method works by measuring the power through current and voltage sensors. Once the power is measured, a signal is sent to adjust the duty cycle of the boost converter. The power is once again measured and checked. If the power is greater than the previous measurement, the duty cycle is adjusted in such a way so as to cause the power to move back towards the higher measurement. If the power is less than the previous measurement, the duty cycle is adjusted in such a way so as to cause the power to increase along the power curve. Next slide. The resistance seen by the solar panel input, indicated by the term in the slide Rn, varies proportionally to 1 minus the duty cycle squared, as shown by the equation. Thus, by varying the duty cycle, we can influence the input resistance seen by the panel. The lines of constant 1 over Rn show the possible points that can be reached on the power curve for the corresponding topologies. We chose to implement our design using a boost converter. The boost converter can access points on the power curve as shown in the image. Research indicates that the boost converter tends to be most efficient when irradiance is high, i.e. in the middle of the day. Next slide.
Other project plans and features added into our streetlight systems were adding 2 additional watt meter monitors, measuring the energy generated from the solar panel, and another watt meter placed on the output of the whole system to get a better understanding of the system's energy consumption. The system's power consumptions consist of the 3 Arduinos, the lighting, IR sensors, and the rest of the smart components used. The benefits of adding these monitors ensures a better understanding of the efficiency of the system and any power problems the solar panel and system may run into. Next.
So here's our overview of our timeline for our project. As you can see, week 1 and 2, we figured out the idea, we ordered and we bought the stuff. So continuing week 3 and 4, we begin to work more on the physical part, constructing our road, painting, etc. Weeks 5 and 6, we begin to assemble the more of the electronic and the wires part. Continuing to week 7 through 10, that's when we begin the code and we begin testing the code. We begin the IR sensors, and that's when we switch the IR sensors to the ultrasonic sensors in between these weeks. So weeks 11 through 14, we finalized the project, we touched it up, and we made sure everything was good to go. Next, please.
All right, so now I'm gonna show you guys a short demo video. It's gonna briefly just show you how our project works. It's not gonna go too much in depth. It's gonna show overall the components, and it's gonna show basically how this works. So. All right, so that's just a brief demo, and I hope you guys enjoyed and understood how our project works. Alrighty, so we come to the conclusion of this presentation. And now as group members, we're gonna share what we did and what we contributed to this group, to this senior project. So I'm Steven Salcido. What I contributed to this project was I pitched the initial idea for this project. I saw something similar to what we did online, and I thought it was a great idea because this is actually something that can be applied or is being applied in real life. And it would really help us to understand maybe something that maybe we might work in that field later in the future, in the Internet of Things, in solar energy, renewable energy. And I truly believe that stuff like this is really going to become the future as we move on and as we move into the industry of electrical engineering, computer science. But yeah, my contribution was pitching the idea. I as well constructed the physical base that you saw there. And I assisted also in the development of the main circuit design of what kind of hardware we're going to use, where we're going to connect to what, and what were we going to connect to what. Basically just a rough sketch and to give an idea to my group of how we're going to do this design.
So my name is Irvin Juarez, and I'm responsible for constructing the main code for the main Arduino circuit in C language using the Arduino IDE software. And I'm also responsible for soldering all permanent connections in our circuit.
So I'm Esteban Linares, and I contributed on working on the physical model design. I suggested the decision on switching from an IR sensor to an ultrasonic sensor due to the testing, and it was failing with the IR. The wiring, touched up some wiring systems, an overview of the code, just a general contribution. Thank you.
Hey, I'm Guadalupe Quinones, and I contributed in the design layout and aiding the wiring of the IR sensors and the lighting system. I also helped in the development of the watt meter monitor and the Arduino code.
My name is Jonathan Street. I was responsible for the design and implementation of the solar panel source circuit and boost converter, as well as the perturb and observe algorithm implemented on the Arduino microcontroller.
All right, well, now we all mentioned what we contributed to this project, and that pretty much wraps up this presentation. We want to thank everybody that watched this video. We want to thank anybody that helped us along the way. We want to thank our Professor Marcia that was there answering our questions, whatever we needed. And yeah, thank you, everybody.